Good morning, everybody. Hello, I'm Marianne. I'm working for Fluidtech Team Europe. So here it's morning, but I know that my speaker, Rafe Britton, is doing this webinar from Australia. So it's almost evening over there. So let's get ready to welcome Rafe Britton, Rafe Britton, technical specialist at lubrication expert, to give us some insight info on It's Always the Oil's Fault, approaching difficult conversations with data. There you go.
All right.
Rafe.
Thanks for that, Marianne. And g'day, everyone. Hopefully you can see the screen, and it's good to see a few familiar names kind of hopping on board. So today I thought I'd do something a little bit different. There's so many experts that are attending today and giving really good discussions on the more technical aspects of oil condition monitoring and formulation and all that sort of stuff. So I thought I'd maybe try a slightly more human elements presentation, for want of a better word. I obviously do a lot of technical presentations and wanted to do something a little bit different here. And so what I thought I could do is talk about difficult conversations with data and some of the root causes in some respects for why the industry finds it so hard. So that the title here is It's Always the Oil's Fault, and how to kind of navigate that sort of feeling around our industry. So broadly speaking, I always like to start these with why am I in a position to really talk about this? What gives me expertise? Because there's not, blaming the oil is something I think we see across the industry. So why do I feel qualified to talk about it? So some of you might know me from the Lubrication Explained YouTube channel. If not, go check it out. What runs alongside that is a podcast called Lubrication Experts. And I have the fortune of just talking to people who are extremely knowledgeable in their field. Not only that, but they cover a very broad range of different disciplines within the world of lubricants. Now, everyone here I've kind of got pictured is actually either presenting at LRVS today or is kind of an alumnus, if you like, of LRVS. And one thing that you'll notice is that they come from all different parts of our world. So whether it's formulation work, it could be oil condition monitoring, online sensors, people involved in additives and base oils, people involved on the user side, kind of the user experience, even people from ICML. And so I get to see a pretty broad cross-section of the industry, and it kind of gives me a unique position to be able to kind of gauge sentiment. Not only that, but my business works all across the industry as well. So I work with additive companies, base oil companies, lubricant blenders, marketers, distributors, as well as end users. And so getting to see that quite broad cross-section helps me kind of get that sort of feeling. And so, there tends to be, let's say, opinions that bubble to the surface or that coalesce together. And this is one of the ones that I've kind of seen has been a little bit common. This is all something I posted on LinkedIn a little while ago. Obviously, I found it amusing, but a lot of the feedback that I got both on the LinkedIn platform as well as offline as well was kind of echoing that sentiment, where they feel like the oil does tend to get the blame a lot for issues which are not necessarily related to the oil. So I thought, let's explore why that might be the case. And first of all, why is it always the oil's fault? That's a really good question, and I think it would help sort of frame the rest of the discussion. So why do I think the oil often gets the blame? For anyone who's familiar with this character, this is from the television show How I Met Your Mother. I don't know whether it was popular in Europe, but certainly in America and Australia, it was quite popular. There was a character called Barney Stinson who explained something called the chain of screaming. And he was talking about it in a corporate context where people vented their anger by basically screaming at someone who is their, it was superiors kind of screaming at their subordinates, for want of a better word. So how does this chain of screaming apply to how lubricant gets the blame. In general, what I see is that there is some kind of event that happens, whether it's a maintenance-induced event or it's a failure of a bit of machinery. Generally, it's a catastrophic failure that's the kind of thing that triggers this. And obviously, these days, management has so much oversight over live data. They see all sorts of dashboards. And what I tend to find in most large organizations is that management is kind of alerted to this enormous failure, and they want answers. It's not necessarily that they're blaming anyone. It's often it's just simply we want to discover the root cause of this problem, and the managers are not in a position to do that from a technical basis. So who do they go to? They go to their engineers, their technicians, their field personnel. And so, okay, they're not necessarily screaming at them, but they want answers. And the technician, right, can look around and say, okay, where do I think the potential root cause of this is? And in a lot of larger organizations now, what we're finding is that a lot of the applications have become so specialized that no technician can really understand the full picture. So generally, as part of this root cause analysis, they're going to need to, get some external help. And who does that external help come from? It generally comes from the OEMs. So let's say, for example, we talked a lot about gas turbines today. There's a huge failure of, let's say it's a frame 9 gas turbine. Generally, the first call that you make is to GE to say, what the hell? What went wrong with your turbine? And this is where the blame game can sort of sometimes derail the conversation when it comes to root cause failure analysis. But now look at it from the OEM's perspective. The OEM doesn't want to immediately take the blame. So they might look at their bit of equipment, whether it's a turbine or it's a compressor or it's a huge hydraulic system, and look at the inputs into that piece of machinery. There is the OEM that built it. They don't want to blame themselves. There is the customer, their customer who operates it. And one of the principles of the chain of screaming is that you never scream up. You always scream down. And so who is the only other input into most machinery? It's unfortunately, it's the oil manufacturer, right? The oil is usually the only other thing that goes into this bit of kit. And so obviously, us being downstream of the OEMs, the lube oil tends to get the blame, right? So we are at the bottom of the chain of screaming. And that's why we tend to cop the blame. But in some respects, when I look inwards into the industry, I think we've made ourselves a bit of an easy target for doing that. And there's a handful of reasons for why I think we're an easy target. The first is when you look at the domains of knowledge. I've spoken about this a few times. Most of the people that are using lubricants, they come from a mechanical engineering background. Maybe they're not engineers themselves. Maybe they're diesel mechanics, right, who have a job as a fitter or a greaser. But most people are coming from that sort of mechanically minded background. And unfortunately, a lot of lubricants is chemistry, right? And so when you look at the overlap in knowledge domains, there is very little overlap. And so one of the things that's incumbent on us as the lubricant industry is we're having to explain some chemical concepts to people who might not have done chemistry since high school or may have never done chemistry at all. And that challenge of translating is something which is difficult. And to be honest, that's something I struggle with. And it's something that I've tried to refine on the YouTube channel because mostly I'm speaking to a mechanical audience. And I'm always trying to seek out how do I explain these chemical concepts to someone who is mechanically minded. You want to explain it in sufficient detail that you are preserving kind of like the truth of what's going on and the truth of the science, but you also don't want to dumb it down so much that it is kind of disconnected. But it's also got to be in a very explainable way. So that's one thing I think that is challenging. But then we don't make it easy on ourselves by doing things like this. Now, I've taken product names out and any references to a specific type of technology, but this is a description of a product in a PDFs. Now, this product I can tell you is actually one of my favorites, right? This is a product which I've used extensively to solve a range of different issues, but you would never know it from this description because it's so generic, right? Effectively, all this is saying is the product is good at low and high temperatures. And that doesn't tell the user anything, And so this is an example of us not adequately translating technical material into something that end users can really grab a hold of and actually use in some kind of context. Sometimes it goes the other way, right? And again, I've kind of removed any references to specific technology here, but this to me is a description in a PDS which is too overflowing with jargon. So you might have heard the term baffle with BS. This uses so many kind of jargon words that it also is meaningless in another way, right? So when we talk about plastic deformation and tribopolymer systems, that doesn't mean anything to our end users. And again, it's a challenge of like taking that technical information, which is based in chemistry, and then pulling it over and translating it to a mechanical audience. Another thing that we face a lot of problems with, right, is oil analysis. Now, oil analysis should be, like when you think about it, it should be the data that we can bring to where everyone can be talking on the same page, right? So end users can come with their used oil analysis data and speak to someone from the lubricants industry, and together we should be able to see this data and work together to determine what is the root cause of an issue. Now, here is a classic example that came up to me a couple of days ago, and this is not a particularly special oil analysis report. This is something that I would see on a daily basis, effectively. And one thing that you'll notice, right, is that there are so many different parts of the chain of screaming, for want of a better word, which have broken here. So, as an example, look at what the lab has done, right? This is very clearly hydraulic oil, right? So if you look at the additive levels, it's predominantly phosphorus, zinc, and a very, very tiny bit of calcium. So it's not an engine oil. The viscosity grade would also suggest it's a hydraulic oil. And in one case, they're testing viscosity at 40. In the other case, they're testing at 40 and 100, right? So we've got variation in the tests that are being applied to the same oil. So there is in some ways, like a failure, for want of a better word, on what the lab is kind of promoting into the world. Then we also have the failure on the part of the user, right? So if you look at the PQ index, that is an awfully high number. So either, right, we are expecting the hydraulic pump to fail imminently, right? I would be surprised that by the time you got this report back, the pump is already done for with a PQ index that high. Or alternatively, maybe we've sampled incorrectly, right? And actually, when I asked for a picture of the sample bottle, so a picture of the retained sample from the lab, yeah, sure enough, it was basically full of metal shavings. And when I asked the customer, where are you taking the sample from? It was pretty much from the sump, right? They dropped the drain tube all the way into the bottom and hadn't taken a sample. Firstly, they weren't taking a sample while the pumps were on and the machine was operating, so they were doing it cold, but they were also taking it from the bottom. And so there's a element of, okay, rubbish data in makes rubbish data out. Now, the third problem that's happened is that the sales person who is the kind of the first point of contact, right? They didn't know what was wrong with this report. And to me, this is one huge issue where no one is focusing on. There's an entire cohort of people that is involved in our business that is not getting any attention, and that's the lubricant salespeople. So if you think about the organizations that are involved in our business, we have STLE and we have ICML. And yes, there is a little bit of overlap there, I get it. But if you could broadly kind of talk about who is their mission aimed at? STLE is really aimed at lubrication professionals. So we've got the likes of lubrication engineers, formulators, people who are base oils and additive specialists. Then ICML is kind of end user facing. They really want to do a great job of educating end users about how to use lubricants, how to preserve them, how to store them, how to handle them, how to analyze them. And both of those are really good missions. But to me, what's left out is where the rubber hits the road. There are thousands and thousands of lubricant salespeople on the road who have very little to almost no knowledge of lubricants. And to me, I think I see this as almost being like an existential problem for our industry, because we have so few technical people coming through that realistically, we're never going to have enough technical people to service the total number of end users that we have in our industry. There are so many end users and so few technically minded people that we need to somehow scale up our knowledge. And we have this army of, if you like, lubricant salespeople who, you know, could do a really good job of like triaging a lot of this work. You know, this kind of stuff, this kind of basic analysis where they could ask, you know, 1 or 2 questions which could really get to the root cause of the problem. That's a massive opportunity that I think we're missing, right? And so how to educate that sort of cohort of people, I think would go a long way to helping our industry kind of get a little bit more credibility. All right, so what tools do we have? Like, how can we improve the situation? I've already talked about trying to train up that sort of single cohort of people, which I feel like are getting missed in that education process. But I think that one really good example of how to communicate technical information actually comes from Apple, right? So when they did their transition from Intel-based to ARM-based silicon, okay, so you know, if you're not super into computers, you might not be aware of what that was, but basically a few years ago, Apple made a transition from using Intel-based chip architecture to kind of bringing the manufacturing in-house. So, you know, they threw up a chart like this, which I would describe as being very generic, right? It doesn't really give you a lot of information, and they were kind of lambasted for this, right? You know, people kind of made fun of them for all the charts that they threw up on screen. Now, remember, this is a consumer-facing organization, right? They're speaking to a very general, non-technically minded audience. But beyond that, right, the next slide that they showed actual hard data as to like good reasons for why, you know, this generation's chip is better than the previous ones. They explained, for example, that manufacturing had gone to a 5 nanometer process. Previously, it was 7 nanometers. Okay, now we have a good reason for why the chips are more efficient and why they're more powerful. You look at the number of transistors that are actually on the chip itself. That number has gone up. So we expect that there's a valid reason for the increase in performance. Now think back to the explanation that I gave on the PDS, how generic it was, how it doesn't explain why this generation's product is better than the previous generations. We do all this hand waving, and we, right, as an industry, are speaking to engineers, right? Apple is speaking to average Joe Blow on the street. So I feel like if they can do it, we can. And I get it, we need to sort of thread the needle between not giving away all of our intellectual property and our formulation secrets, but at the same time, I think we can do a better job of informing the people who use lubricants so that they can make, you know, better decisions. And of course, you know, Apple has a product line where they have to distinguish between, you know, why should you buy the upgraded version? And again, I felt like just with some simple graphics, they were able to, you know, adequately convey why that is that you would make that purchase decision. So one thing that I think that we could do is demystify a lot of things with some very handy frameworks. I use this example in hydraulic oils, for example. I get a lot of customers who are very confused about the hydraulic oil space. How on earth am I supposed to pick something? And at a very basic level, I try and define for them. Hydraulic oils are kind of split into standard viscosity index and high viscosity index, and low zinc and high zinc formulations, right? Now, there are some specialty applications, but if you don't fall into that bucket, you don't need them, right? And what do the dimensions represent, right? So viscosity index is related to the operating temperature range and your hydraulic efficiency. And, you know, whether you have zinc or not, that's reflective of the anti-wear performance, but also sludge formation. And, you know, I feel, at least the feedback that I've been given from customers is, oh, wow, that has really simplified the choice, but in a way where I can understand the underlying chemistry and why I would make that choice. But, you know, so far, I haven't really seen this kind of represented anywhere, giving people sort of like easy decision points, right? So that would be one example of how we could potentially, you know, sort of improve our communication. The other way that I would like to do it, and I'm sort of a big proponent of this, is how do you kind of animate the data as well? So, you know, let's say, for example, and I think I've seen this actually on fluid learning. I think there was an example a little bit like this, where it showed kind of what happens to the varnish thickness as well as the overall temperature over time, to help explain to people exactly why it is that you see variations in bearing temperature. And a very, very simple and quick animation often is easier than having to explain something and getting people to visualize it and map it onto the data that they've already seen. So being able to do that, and I mean, I'm just doing this in PowerPoint here, like I do with all the animated data that's in on the YouTube channel. It is a very cheap and effective way of kind of communicating that. So anyway, that's kind of everything that I wanted to present today. I know I kind of got on a bit of a high horse about, and I'm not meaning to bash anyone in the lubricants industry for sure. I do think though that it's kind of incumbent on us. We have all these fantastic people, at LRVS. Look at all the people who are doing really cutting edge research and development, either in development of new molecules, or else, so new molecules that can solve issues, new filtration technologies, which are fantastic, and I see a lot of promise in them. I also see a lot of work being done in calculation, for example, of carbon emissions associated with our products, and all of this work is going in, and we just need to communicate it to the end users so that they see the value in our industry. So that's all I've got. If anyone has any questions, I would love to take them. I might actually just address, while anyone thinks up of a question. Vander, as always, great contribution, and has mentioned it's always important to perform the visual observation when collecting the oil sample. Yes, right. And this is an example of where just a tiny, tiny bit of education can go a really long way. I was actually very surprised that the lab did the full suite of tests for that hydraulic oil, because usually when they see visible sediment, they don't run the full battery of tests because it can damage some of the equipment in the lab. So usually, a visual inspection of the sample is usually kind of like the first line of defense. And if you see massive discoloration, if the smell is really weird, or you do see visible sediment, then that should be ringing alarm bells that either there is something catastrophically wrong in your oil system, or else there is potentially something that's gone wrong from a sampling perspective. Greg's actually just asked a question. Do you think that your hydraulic oil example could be adopted, or to explain performance, could be adopted to gear oils, turbine oils, paper machines, and other applications? So in I think what Greg was referring to was the kind of the framework that I'd come up with for how to select a hydraulic oil. And I do think that in most instances there are kind of basic performance dimensions that you might want. So off the top of my head, I think I have put one of these together on gear oils, for example. Probably what you're looking at is effectively, your temperature or your operating environment versus your load, right? Your speed and your load characteristics, and so that will determine, whether I need some kind of synthetic formulation and how much EP additive do I need in a gear oil, for example. So again, putting together some very simple performance dimensions would help a lot. Turbines would be another good example. I can, again, trying to think off the top of my head, probably the operating temperature or the operating envelope would govern how much varnish you're expecting to produce. And so there are some formulation dimensions on which you might want to select a turbine oil. And then whether you're using whether it's going into a gas, steam, or combined cycle turbine would determine, for example, the water separability properties that you would want. I do think there are some relatively simple frameworks that can be put together for most applications. Oh, and there was a question from Bruno as well. How can we use more environmentally friendly oils without suffering from electrostatic discharge? Great question. Okay. So I've only got a couple of minutes to answer this one, but electrostatic discharge is probably a topic that's going to be covered at LRVS because it is sort of a hot topic at the moment. excuse the pun. So electrostatic discharge. There's a number of different ways that we can approach it, right? So, and it depends on what kind of application. So there are, for example, like low static filters that do not generate as much static charge at the moment. I'm actually working with a handful of additive suppliers that are looking at drop-in additives to improve conductivity of oils. So that is potentially another option that's on the horizon. Let's say, for example, in some instances, people are going with low conductivity oils where they don't need to. So one of the reasons I know it's multifaceted, but one of the reasons why we've gone to low conductivity formulations is we've removed a lot of the metal containing additives. But in a lot of cases, like a zinc loaded hydraulic oil will do perfectly well if you're not operating at high temperatures where the Z molecule will break down. So in instances where you can use a zinc containing hydraulic oil, then why not? So there are kind of like a range of things, and then obviously you've got a range of things which are not related to the lube oil at all. Are we grounding all our pipe work adequately, for example? So that's another example. So hopefully I answered that, Bruno. And from Mr. Tanaraj, for turbine hydraulic control fluids, what is the recommended particle? Oh my goodness. I've got to be honest, I do not know the answer to that. For turbine hydraulic control fluids, I think there are some recommendations around sort of like cleanliness. And I want to say like around a little bit lower than a 1411 is probably around where you want to hit, but I'd have to look at the documentation if I'm going to be honest. And I think that's about time. Maybe one last question that I can address from Mr. Tanaraj. In some of the turbine oils, customers have requested an electrical conductivity test. Why? So broadly speaking, right, there are some guidelines around what kind of conductivity will help avoid electrostatic discharge. So the API has actually put out a number of above 50 picosiemens per meter. They suggest that you won't see ESD. Our experience in the field indicates that that's probably too low, and oils up to probably around 450 picosiemens per meter, right, will experience some level of ESD. Once you get beyond that 450 number, then the risk tends to be reduced. But it's not just a function of the oil formulation, it's also a function of the formulation, as well as kind of the operating environment, how much low temperature flow is going on, the filtration that you're using. So it's a range of factors. All right. Thanks, Marianne.
No, thank you.
Thank you for listening in.
Thank you very much for your time, Rafe. I'm going to end the webinar now. Thank you.
Sounds good.
Bye.